Hello everyone and welcome to the lecture on kubectl deploy commands, and this is the part 1. So first we'll set the alias k equal to kubectl. So first command is create basic deployment. So k create deploy followed by the deployment name, what image we want and how many replicas. So this command creates a basic deployment named nginx deploy using the nginx 1.20 image with 3 replicas. The deployment will manage the desired state of the pods. And you will get a message saying that deployment is created, and this will be the backend deployment structure. So you have 3 replicas, you have the image over here, and all the labels, all those things will be set up automatically. So next command is create deployment with custom labels. So k create deploy web app followed by the image name, how many replicas you want, and any custom labels that you want to provide. So in this case, we are saying labels app equal to web and environment equal to dev. So this command creates a deployment named web app using the HTTPD 2.4 image with 2 replicas and applies custom labels for application identification and environment classification. So you will get a message saying that deployment web app is created, and then you will have the custom labels. If you don't specify the custom labels, it will just set up the labels depending on. So these are the custom labels, and without these custom labels, it will just set the name of the application as the label. So next is to create deployment with resource limits. So k create deploy, name of the deployment, which image you want, how many replicas, and these are the limits. So these are the upper limits. So we are saying you can consume up to 5500 millicore and 256 MB of memory. So this command creates a deployment named API server using the node 16 Alpine image with resource limits of 500 millicore CPU and 256 MB memory to ensure controlled resource consumption. So you will get a message saying that API server deployment is created, and here you will see the complete YAML. So this is the backend, how it is stored. So it is within the container section, this information will be stored. So these are the limits. So we have 2 sections, like under resources we have maximum and request is the minimum. Okay, next is to create deployment with environment variables. So k create deploy, name of the deployment, which image we want, how many replicas, and any environment variables. So in this case we are saying Postgres DB equal to my app, and one more env Postgres user equal to admin. So this command creates a deployment named database using the Postgres 13 image with environment variables for database configuration, setting the database name and user. So you will get a message saying that database is created. In case you have any error, it will show that okay, there is an error, and this is the resulting YAML in the backend database or in the backend configuration database. So you will observe under the spec section there is a containers, and the containers will get the environment variable. So this database automatically, the Postgres database will be my app and the user will be admin. Moving on, create deployment with port configuration. So k create deploy, name of the deployment, image name, how many replicas and port. So this command creates a deployment named frontend using the nginx 121 image with 3 replicas and configures port number 80 for the containers to handle web traffic. So you will get a message saying that frontend deployment is created, and this is the backend configuration. So the port information goes to the containers because the containers are the objects which serve the traffic, right? Okay, moving on. Create deployment in specific namespace. So k create deploy, name of the deployment, which image we want, how many replicas, and in this case we are saying this deployment should be created in production namespace. So till now we have created all the deployment in the default namespace. This command creates a deployment named Redis using the Redis 7 Alpine image in the production namespace, demonstrating namespace isolation for environment separation. So you will get a message saying that deployment is created, and this is the part where it will have the namespace equal to production. Moving on, get deployment information. So k get deploy. So this command lists all deployments in the current namespace, which is the default namespace, showing their desired replicas, current replicas, up-to-date replicas, available replicas, and their age. So you will get output like this: name of the deployment, how many are ready. So based on a number of containers, how many are ready, how many are up to date, available, and the age of the deployment. So get deployment details. So k get deploy and specific nginx deploy, and we are saying output equal to void. So this command provides detailed information about a specific deployment, including images, selectors, and strategy, offering comprehensive visibility into the deployment configuration. So you will get the complete information, and that's why we have specified output equal to void. So name, ready, up to date, available, age, which containers it's running, what images, and the selector. Next is to describe a deployment. So k describe deploy, name of the deploy, and this is in the default namespace. So this command provides comprehensive information about a deployment, including configuration details, current status, replica sets, scaling history, and events for troubleshooting purposes. So you will get the complete description of the deployment. So name, namespace, labels, annotations, selectors, how many replicas to desire to update it to total, available, 0 unavailable, what is the strategy type, rolling update, and rolling update strategy, 25% max unavailable, 25% max search, and any labels, which containers is running, image, what ports is exposed. And the important part is, if you want to do any troubleshooting, you can go to the event section and see any events are failing or not, like image pullback, or some images not found, or you have given the wrong image label which does not even exist. So you will get in the events. Moving on, scale deployment replicas. So k scale, name, deployment object, name of the deployment, and replicas. So we are saying scale to 5 replicas. So this command scales the nginx deployment to 5 replicas, and that allows you to increase or decrease the number of running instances based on demand or resource requirements. So we are manually scaling the deployment. You will get a message saying that it is scaled, and that's all. Edit deployment configuration, k edit deploy, and web app. So this is if you want to make a quick update and this object already exists in the system. So we are saying edit deploy web app. So this command opens the deployment configuration in the default editor. So mostly it will be VIE, and that allows you to modify deployment specifications such as image versions, replica counts, environment variables, and resource limits. So the whole thing will open up in the default editor. So if it's a Linux, it will be VI editor, and you can, whatever you want to change, you just go to that section or that object, and most likely it will be the value, or if you want to add something also, you just add and save, and it will be automatically update in the system. Next is to update deployment image. So k set image deploy, followed by the deployment name nginx. So this is one of the container, and we are saying nginx 1.22. So let's say there is an older nginx image, let's say 1.21, and we are updating. So let's say in a production environment, this is what happens most of the time. We update the image, and based on the application, let's say we have updated the application, the image will get updated, and we update the image. So this command updates the image of a container in a deployment, and this triggers a rolling update to deploy the new version while maintaining service availability. So you will get a message saying that image updated. Check rollout status. So k rollout status, deploy, and the name of the deployment, web app. So this command monitors the progress of a deployment rollout. So if you have done a set image, you can check out the rollout status, and this provides real-time updates on the status of the rolling update process until completion. So you see one by one all the number of replicas. So let's say there are 3 replicas or 4 replicas. It will give all the status saying that it is being updated one by one. So you will get message saying that waiting for rollout to finish. 1 of 2. In this case, it's 2 replicas. So 1 of 2 updated and 2 of 2 updated, and finally the web app is successfully rolled out. View rollout history. So K rollout history, deploy, and the name of the deployment. So this command displays the rollout history of a deployment, showing revision numbers and change costs for tracking deployment changes over time. So you will see all the revisions and change costs. Undo deployment rollout. So K rollout undo deploy API server. So this is just to undo the latest. So you have just, let's say, set image, there's some issues, you just undo and you will go to the last previous version. So this command rolls back a deployment to the previous revision, providing a quick way to revert or roll out problematic updates and restore the previous working state. So you will get a message saying that it's rolled back. Roll back to a specific revision. So K rollout undo deploy to revision. So first you have to check out the rollout history and then you will go back to a specific revision. So this command rolls back a deployment to a specific revision number, and that allows precise control over which version to restore from the deployment history. You will get a message saying that it is rolled back. So pause deployment rollout. So K rollout pause deploy web app. So let's say you are doing a rollout or you set an image or something, you want to pause. So this command pauses the rollout of a deployment, stopping the rolling update process to allow for inspection or testing before continuing the deployment. So you just got, let's say, one of the replicas failed. So you just do a pause and you first troubleshoot and then you can resume. So it will say web app paused. Then you resume. So K rollout resume deploy, name of the deployment. So this command resumes a paused deployment rollout, continuing the rolling update process from where it was previously paused. So we'll get saying that K, so you'll just say rollout. So this message is wrong. So resumed. It will just say web app resumed. Restart deployment. So K rollout restart deployment, name of the deployment. So this command restarts all pods in a deployment by triggering a rolling restart. And this is useful for applying configuration changes or refreshing the application state. So we get a message saying that it is restarted. Delete deployment. So K delete deploy, name of the deployment. This command deletes a deployment and all its associated resources, including replica sets and pods, completely removing the deployment from the cluster. And you will get a message saying that it is deleted. Apply deployment from YAML. So if there's a YAML file, you can just do apply -f and the YAML file name. So this command creates or updates a deployment based on the configuration specified in a YAML file, supporting infrastructure as code and declarative deployment management. So let's say this is the whole deployment and this is in a file. So whatever is declared, it will be, if it's not there, it will be created, or if it is already there, it will be updated or configured. Create deployment with node selector. So K create deployment. Let's say name of the deployment we are creating, image is TensorFlow, and this is the exact image tag, 1 replicas, and we are saving it to first a file. Then we will edit the file, this particular file. So that's why we are doing dry run. So it is not saved to the cluster, and we'll add a node selector saying that this deployment should run on node which has this particular label set, GPU equal to true. So you do a apply F. So this advanced commands creates a deployment with node selector constraints, ensuring pods are scheduled only on nodes with specific labels like GPU enabled nodes. So this was the initial YAML from this particular command, GPU app.yaml. And what you will do is you will add, so this is under this particular section. So under spec, there is a one more spec, node selector GPU equal to true. And you just save the file and apply the file. and you will get a saying that GPU app created. Then this deployment and pods of this deployment will only run on nodes which have this particular label. Expose deployment as a service. So k expose deployment name and the port of the deployment and the target port. So this is the service port and this is the target port of the containers, the pods container 8080, and the type of service is cluster IP. So we can directly expose deployment as a service. So this is the fastest and most efficient way. So this command creates a service to expose a deployment, making the application accessible within the cluster with load balancing across the deployment pod. So you will get a message saying that service web app exposed, and this is the important bits in the resulting YAML. So this is how it will look like. So you have this particular the front end port, like from where the traffic is served, and the backend port, and the type of service, cluster IP. And next, create load balancer service for deployment. So k expose deployment name. This is a load balancer port, the containers port, pods container, and the type of service. So this command creates a load balancer service for our deployment, providing external access to the application through the cloud provider's load balancer. So you'll get a message saying that front end expose this service, and this is the pitch. So we have seen this already, but only thing is type is different. It is load balancer. In the previous case, it was cluster IP. Next, create node port service for deployment. So there are three types of service: node port, cluster IP, and load balancer. So this is the third part, node port. Expose deploy, name of the deployment, and the port, container port, the pods container port, target port, we are saying 3000, and type equal to node port. So this command creates a node port service for a deployment, making the application accessible externally through a specific port on each cluster node. So API server exposed service, this will create a service, and this is the bits. So here the target port, backend, and the front end 8080, and type of service node port. And that's all. Thanks for watching.